development, growth, and remodeling of bones. October 17 to 20, 2014. Important vocabulary. What is an osteocyte? A mature bone cell. 2 new words. Osteoblast, bone-forming cell. Osteoclast, bone-dissolving cell. Mnemonic. Osteoblast, bone-building. Osteoclast, bone-consuming. Bone growth and development. Embryonic skeleton, A, is made of hyaline cartilage. As a fetus, B. Osteoblasts form a bone collar around the diaphysis. Osteoclasts digest cartilage and center of diaphysis. Osteoblasts form spongy bone in the diaphysis. Cartilage in other areas. Continues to grow. D, C, E, B, A. Bone growth and development. As a newborn, C. The medullary cavity forms. The epiphyses begin to ossify. Throughout childhood, D, and adolescence, E. Bones grow in length and width. More on this. Cartilage is replaced with bone. Compact in diaphysis and spongy in epiphysis. Bone growth. D, C, E, B, A. How do these X-rays demonstrate bone development? How do these X-rays demonstrate bone development? The infant has a high percentage of cartilage, which doesn't show on X-ray, whereas the 8-year-old's hand is mostly bony. Notice the epiphyseal plates. Growth in bone length. Epiphyseal end of growth plate. Cartilage on the side of the epiphyseal plate close to the end of the bone grows by mitosis. Diaphysis end of growth plate. Cartilage on the side of the epiphyseal plate close to the diaphysis calcify and die. Osteoblasts develop spongy bone around the dying cartilage. Osteoclasts dissolve the dead cartilage. Growth in bone length. During most of childhood, the rate of cartilage growth equals the rate of cartilage destruction, bone formation, so the epiphyseal plate width stays the same length. Near the end of adolescence, cartilage growth slows and stops, so the epiphyseal plates narrow then close, are replaced by bone. Fun fact. Ages of plate closure. Girls, 18 years. Boys, 21 years. Growth in bone width. Bones grow in width using a process called appositional growth. Osteoblasts under the periosteum secrete bone matrix. Osteoclasts near the medullary cavity dissolve bone, enlarging the cavity. The osteoblasts create new bone at a slightly faster rate than the osteoblasts destroy bone. This means the bones get wider and slightly thicker as they grow. Bone growth. Think, bear, share. Where in the bone does bone deposition, bone building, occur? Where does cartilage grow? Where is bone resorbed? Regulation of bone growth. Hormones regulate bone growth during youth. Growth hormone, secreted by pituitary, is the primary hormone responsible for bone growth in infancy and childhood. Testosterone and estrogen, secreted by testes, ovaries, cause a growth spurt in adolescence. Cause the masculinization, feminization of the skeleton. Later cause epiphyseal plate closure. Although most bones stop growing in late teens, some of your facial bones, for example nose, jaw, grow throughout life. The termination of growth is done by estradiol metabolites, which is why it occurs later in men. Compared to females, male skeletons have heavier bones, enlarged rib cages, smaller pelvic opening, larger brow, mandible, and occipital protuberance. Bone remodeling. Throughout our lives, our bones are constantly remodeled. Old bone is digested and new bone is formed. Purposes of remodeling: regulate blood calcium, repair damaged areas, add strength to areas that need it, maintain proper bone shape throughout growth. Process of remodeling: osteoclasts break down bone tissue and release calcium into the blood. Osteoblasts create new bone tissue, taking calcium from the blood. Fun fact: spongy bone is replaced every 3 to 4 years, compact bone is replaced every 10 years. Bone density in athletes. We obtain microscopic cracks in our bones due to daily activities. Older women are encouraged to do weight-bearing exercises to increase bone density. Astronauts lose density. Regulation of bone remodeling. Bone remodeling is controlled by 2 factors. Hormones that regulate blood calcium levels, determines whether more deposition or resorption occurs. Mechanical stress determines where more bone is needed. We obtain microscopic cracks in our bones due to daily activities. Older women are encouraged to do weight-bearing exercises to increase bone density. Astronauts lose density. Calcium has many uses in our body. Precise levels of calcium are necessary for nerve impulse transmission, muscle contraction, blood coagulation, cell division, hormonal regulation of bone remodeling. We obtain microscopic cracks in our bones due to daily activities. Older women are encouraged to do weight-bearing exercises to increase bone density. Astronauts lose density. The role of mechanical stress. Although the role of mechanical stress, how much tension and compression bones experience, is not fully understood, we do know that areas that experience greater stress have greater bone deposition. Areas that experience little stress have greater bone resorption. We obtain microscopic cracks in our bones due to daily activities. Older women are encouraged to do weight-bearing exercises to increase bone density. Astronauts lose density. Without gravity, astronauts have little stress on their bones. As a result, they lose bone density at an alarming rate. Astronauts on Mir lost 1.5% bone mass per month. Compare this to postmenopausal women, who lose about 2.5% per year. You do. Compare and contrast bone growth and length, appositional growth, and bone remodeling in terms of process, location, timing, and regulation. Closure: what were our objectives and how did we accomplish them? How does it relate to our overall unit question? Our mini question,